Hey, this is Math 6, Unit 6, Lesson 13, Expressions with Exponents. So the first one is which one doesn't belong. Okay, so we're looking at some 2's, it says. So which one do you think doesn't belong in this group of 4? Which one do you think doesn't quite belong here? And there's different ways of looking at them for why you think which one may or may not belong. They're all a little different when you look at each one. This one, for example, shows expanded multiplication, 2 times 2 times 2 times 2. The rest don't have that many. This is just all 2's and expands that way. Okay. This one is the only one with an exponent in it, so maybe that's why you would think that one doesn't quite belong. This is the only one with just a whole number in it, so maybe that's why. And this is the only one that shows a multiplication of two things, plus it's the only one that equals something different altogether, because 4 times 2 is actually going to be what? 8. And this is 2 to the 4th like that, and 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. So this one actually equals 16. So all these are 16 except for that one, so maybe that's the one that doesn't belong, but they all maybe don't belong for kind of how they are set up or look as well. Anyways, that's up to you and what you and your classmates come up with. It says next activity is which equation is true, or is the equation true? To decide whether it's true or false and explain how you know. So for the first one, we have 2 to the 4th power. Now when you look at 2 to the 4th power, 2 to the 4th power means I'm going to have 2 times 2 times 2 times 2. Now, is that the same as 2 times 4? We would say no. This is two groups of 4. In other words, it's 4, 4 times, it's like 4 plus 4 is how that works out there. This is 2 times 2 times 2 times 2, which we've already decided is 16. So we know that's 16. 4 times 2 is actually 8. So those do not equal each other. We would say this is going to be a false statement. I'll put there in the front. For this one, we have 3 plus 3 plus 3 plus 3 plus 3, and we could think of this as like, well, that's all 3's, and you might be quick to say, well, it's 1, 2, 3, 4, 5 of them. Hey, that's great, except for what? This is adding. And with exponents, you're looking at repeated multiplication, right? Not addition. This is actually 1, 2, 3, 4, 5. This is 5 groups of 3 is what you actually have there, not 3 to the 5th power. Because this works out to be 15, and this one is not 15. What is 3 to the 5th? I'm not actually sure. So I'll use 3, and use my little caret, and do 5, and then we have equals 243. So that is going to be a false statement there. Alright, how about this one? 5 to the 3rd. 5 to the 3rd is 5 times 5 times 5. And look at that. That equals the right side, which is already 5 times 5 times 5. So that is a true statement. We have one true one so far. Way to go. The next one, 2 to the 3rd equals 3 squared. Now, it could, by chance, work out to be the same, but in this case, it does not. Let's see why. 2 times 2 times 2 is 2 times 2 is 4, 4 times 2 is 8. And for the 3, we have 3 squared. 3 times 3 is 9. Well, those do not equal each other. 8 and 9 are not the same, so we would say it's false. 16 to the 1st is simply 16. Great. Now they put it here because you might think, oh, 8 squared. Yeah, right. It's 8 squared. 8 times 8. That is not 8 times 2. 8 times 2 would be 16. 8 times 8, though, is 64. Those are not equal. That's another false statement. On this one, we have halves, and here we have 4 groups of a half. In a sense, yeah, I can see the halves 4 times. 1, 2, 3, 4. But I'm multiplying them together, which means this expression right here is actually a half to the 4th power. That is not equal to 4 times a half, because 4 times a half is going to be 4 over 2, whereas this is going to be 2 times 2 is 4, times 2 is 8, times 2 is 16, 1/16. And this can be reduced down to 2, so we would not say that 1/16 is equal to 2. So that's going to be a nope, false statement. The next one, a half to the 4th power equals 1/8. Well, it's looking closer, but let's take a look. This is a half to the 4th power. We just said a half to the fourth power was what? 1/16. So a 16th is not equal to an eighth, so that's also false. If this had been a third, that would actually work, but it's not. Now look at this one. We have 8 squared. 8 times 8, which is 64. Here we have 4 to the third, and 4 times 4 is 16, and 16 times 4 is 64. This is actually a true statement. So of all those, we have 2 true and a whole bunch of false. All right, exciting. So just good practice here is what we're doing today. Lots of practice. Activity 3. What's your reason? In each list, oops, zoom down here. In each list, find expressions that are equivalent to each other and explain to your partner why they are equivalent. Your partner listens to your explanation. If you disagree, explain your reasoning until you agree, and then switch roles for each list. So you can have partner A can do this one, partner B, partner A, partner B, partner A, partner B, or however you mix up your class. So let's pretend I'm partner A. All right, well, what do I see here that might be equivalent? I have 5 times 5, okay. I have 2 to the 5th power, which is 2 times 2 times 2 times 2 times 2. I have 5 squared, which is 5 times 5, and I have then just simply 2 times 5. While I'm looking at this, I would say that A and C are equivalent. And the reason I would say A and C are equivalent is because 5 times 5 is the same as 5 squared, because 5 squared means to multiply 5 times 5, and that's why they are equivalent. The other ones just don't quite work out. And I can prove it to you because 2 times 2 is 4, 8, 16, 32. That's not what I'm looking for there. And this one equals 10. So just in terms of their values, A and C are the ones that are actually equal if you were to solve them out there. Okay? So that's what you're going to do with your partner. You're going to do that for A, for number 1, and do it for the other ones as well. Now, I will give you a little hint here as you work on this with your partner that number 5, there are not just 2, because notice here, there may be more than 2 equivalent expressions in this list. Take a look at number 5 when you get there, okay? So I want you to do the same thing for both of these activities, or for the rest of these. I'm going to look at number 6 real quick, okay? And then with partners, you can split up the other ones if you're doing it in class. So this is a great one because we're doing the fractions, and I like fractions. So 5 to the third squared means what? 5 to the third times 5 to the third. Well, to do fractions, I multiply. 5 times 5 is 25. 3 times 3 is 9. So just rewriting that there. 3/5 squared is 3 to the 5th, or 3/5 times 3/5. So 3 times 3 is 9, and 5 times 5 is 25. Here we have 10/6, which I can reduce that to 3/5, or not 3/5, 5/3. But it just becomes 1 of the 5/3. And here we have 25/9. So by multiplying or doing exponents and solving it out, I can see that A and D actually go together. C is close, but it's just one group, right? And I need another one. This is actually 5/3 times 2 over 2. But that's what that is. This is 5/3 times 2 over 2. That's how you'd get with 10/6. In case you wonder, how do you find a number like that? That's how they got that. So A and D go together, but I just want to show you how to do exponents with a fraction right there. All right. In summary, when working with exponents, the bases don't always have to be whole numbers, right? We can have a base that is a fraction, like 2/3, and then we just repeat the 2/3 times 2/3 times 2/3 times 2/3. That's fine. The bases can also be decimals, like 1.7, and you just repeat that again and again. So for your bases can be decimals, fractions, they can even be variables like x. That's okay. And it still means the same thing. X to the 5th means I multiply x times itself 5 times. Alright, that's really it for today's lesson. So we're going to pause there, let you work on your homework, and we'll come back and check it together in just a few minutes. Here we go, homework time. Select all the expressions that are equal to 3 times 3 times 3 times 3 times 3. Well, we have 1, 2, 3, 4, 5 3's there. So because we are repeating this multiplication of 3, or tripling it 5 times, this is the same as saying 3 to the 5th power, because there are 5 of those guys there. And I can see that right here in B. That one works out great. Now, it does say select all, so let's be careful here. Are there more? Yes, there are more. 3 times 5 is not correct. That's 15. Not going to work out. 3 to the 4th times one more 3. Well, that's like stopping here and saying, well, let's group that up, and we'll call that 3 to the 4th, and then we'll multiply by one more 3. So that is okay as well. 5 times 3 is the same as this one, so that's a no. And then 5 to the 3rd is something very different. That's 5 times 5 times 5, which actually equals 125. Not quite what we're looking for there. Number 2, Noah starts with 0, then adds 5 4 times. So here's Noah. What does Noah do? He adds 5 4 times. So he does 5 plus a 5 plus a 5 plus a 5. Diego starts with 1, then multiplies by the number 5 4 times. So 5 times a 5 times a 5 times a 5. For each expression, decide whether it's equal to Noah's or Diego's result, or neither. All right, so this one is 4 groups of 5. Where do I see 4 groups of 5? Well, here I have a group, a group, a group, a group, 4 groups of 5, right? And I'm adding them up, and that's what multiplication means. It's repeated addition. So this is 4 groups of 5. This would be Noah's right here. Makes sense. Do I see 4 plus 5 anywhere? Nope. So that's going to be a neither. How about 4 to the 5th power? That would be 4 times 4 times 4 times 4 times 4. Nope. I don't see it anywhere. That would be a neither. And 5 to the 4th power? 5, 1, 2, 3, 4. That would be Diego's right here. Okay, so that's the idea behind those ones. Man, these are very different answers, right? They're very different things. Repeated addition, repeated multiplication. This is 4 groups of 5, which equals 20. What does this actually equal? Well, let's just take a look real quick. If I did 5 to the 4th power, 5 caret 4, I end up with 625. I'd say those are a little bit different. All right, number 3. Decide whether each equation is true or false, and explain how you know. So a lot like our lesson today as well. So this one is 3 to the 5th power on this side, and here we have 9, 9, and 3. Well, I could break the 9 up into 3 times 3 times, and I could break this line up into a 3 times 3, and I still have a 3 there. How many 3's do I have? I have 1, 2, 3, 4, 5, so I actually have 3 to the 5th power equals 3 to the 5th power. So that one's actually going to be okay. Here we have 7 plus 7 plus 7. Well, in the math world, that's going to equal 21, right? And just adding them up, 21. I can think of this also as being 3 groups of 7. Okay? How about this side? Here we have 3 plus 3, which is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18, plus 3 is 21. So that works out okay as well. Is there an easy way to show that? Yeah, this is how many groups? 1, 2, 3, 4, 5, 6, 7 groups of 3. And as we know, 3 times 7 is equal to 7 times 3. So this is going to be a true statement as well. Here you have a 7th times a 7th times a 7th equals 3 over 7. Not exactly. That would work if this was what? If this was addition, sure, that would work out just fine. But we're multiplying. When I multiply things, I multiply straight across. So 1 times 1 times 1 is equal to 1, and 7 times 7 times 7 is not equal to 7. What is it equal to? Well, let's just find out. It's 7 times 7 times 7, which equals 343. That's a number that just rolls off your tongue, huh? 343. I would say that does not equal 3 over 7. Just a hunch here, but I'm thinking, nah, not going to work. All right, 4 to the 1st. That's 4 times nothing. 4. Over here we have 4 times 1. That happens to be 4. So that's going to be true. Over here, this is 6 plus 6 plus 6, which is like 3 groups of 6. That does not equal 6 times 6 times 6. There's no way those are equivalent. That's not true. All right, we're going to do 4, which is in a couple parts here. I have more on the next page. So we have a square. What's the area of a square with a side length of 3/5 unit? So a square, 3/5 and 3/5 on each side. So the area is going to be 3/5 times 3/5, which in our case would be 9 over 25 units squared. So that's the area of the square, is 9 over 25 units squared. All right. So the next one says, what's the side length of a square with area 1/16? Well, so we're looking at it this way. We're saying, okay, we have a square, and the area on the inside is 1/16. So what numbers here and here multiply together to get you to 1/16? A way of thinking about it could be like this. 1 over what number times 1 over the same what number equals 1 over 16. Oh my goodness, I'm off the page. I'm doing this lovely work for you. And you can't see it. So there's my box. I know the area is 1/16. These two numbers multiply together to get 1/16. Now the reason I put 1 over x and 1 over x is because I know the top number has to be 1. Because when I multiply it together, 1 times 1 has to equal 1. So now you want to think to yourself, what value of x can you multiply by itself to get to 16? And hopefully you know some math facts, and you recognize that this should be 4. Because 1 over 4 times 1 over 4 equals 1 over 16. So what becomes our side length? One side length in our case is simply 1/4. Alright, that's our side length, is 1/4. For volume, what's the volume of a cube with an edge length of 2/3? Well, volume is going to be 2/3, so it's a side times a side times a side. It also can be written as 2/3 cubed, right, if you want to think of it that way. So when I solve this out, I have 2 times 2 is 4, times 2 is 8, over 3 times 3 is 9, times 3 is 27. So that's the volume, and that'd be units cubed. All right, now working the other way. What's the edge length of a cube with a volume 27 over 64? So we want to think about going the opposite direction. 27 over 64. Now the nice part here is this. If you look back to the work you just did, do I know how to get to 27? Sure, it's 3 times 3 times 3. So I'm going to keep the 3 here. I know 3 goes on top because it gets me to 27. So what's going to go on the bottom to get me to 64? It's not 2. We've already used 3. You could try 4. Well, 4 times 4 is 16. And 16 times 4 is, hey, what do you know? 64. So just kind of some trial and error there. You can find out that one edge length is going to be 3/4. Okay, that's the idea. Number 5. Select the ones that represent the area of the shaded rectangle. Keep that in mind, shaded rectangle there. So we know that the whole thing is 10, right? So the whole area of the entire thing is actually 3 times 10 is 30. And then we have to subtract this part here. Well, what is this part? This is 3 times c, 3c. So one way of looking at it is like that. I could look at it that way. I could also look and say, well, I'm going to multiply 3 times the whole thing. Well, the whole thing is 10, and I don't want to count the c, so 10 minus the c. And that will give me what's left right there. So these are a couple ways of looking at it here, and you can see that this is the same. I've just factored out the 3. 3 times 10 is 30, and then in this case here, 3 times negative c is negative 3c. So let's look at our choices. I can see this one right away is choice A. This is the backwards way. This is going to be subtracting this from the whole thing, which is actually subtracting the whole thing from c. So that's not going to work out. That's getting your facts wrong. We want to do 10 minus c to find out what the value of that's going to be. So that's backwards. Multiplying 10 times c minus 3, nope. Multiplying by 10, well, no. And over here, we have 30 minus 3c, which matches that one. Perfect. And then 30 minus 10c. No, not going to work. You can't have both of those. So we're going to go with A and E. All right, a ticket at a movie theater cost $8.50. One night the theater had $29,886 in ticket sales. Way to go. Estimate about how many tickets the theater sold. Okay, let's estimate. Well, this is about $10 a ticket, and they sold about, let's round this up, about $30,000 worth of tickets. So, to estimate this out, again just rounding things around, we would divide this by 10, which would tell us that they sold about 3,000 tickets. If that's about a $10 ticket and you sell 30,000, that means each ticket costs, well, $10 times 3,000 gets you 3,000 tickets, gets you $30,000. So we'd estimate about 3,000. Again, it's an estimate. How many tickets did they actually sell? Now we have to figure that out. Well, to figure it out, we have to do $8.50, and we have to look at the price, $29,886, and now we have to do some math. So $29,886 divided by 850 is actually going to work out to 3,516. I'm going to write my answer right there. You should show some work to get credit. So be ready if you don't. Number 7. A fence is being built around a rectangular garden that is 8.5 by 6 1/3 feet. Fencing comes in panels. Panels are 2/3 of a foot wide. How many panels are needed? Okay, so here's our picture. We have a line here that's 8.5. Then we're going to go 6 1/3. We go this way 8.5, and then we go this way 6 1/3. And we have 2/3 foot panels. Okay, so meaning that if I had a foot like this, so this is 1 foot, the panel is 2/3 of a foot wide, right? So the panel is going to cover up this much, right? That's 1 foot. If I did 2 feet, right? Here's another foot. There's 1, 2. I'd have another 2/3. I'd have one here and here. And then I could do another one here and here, right? So in a 2-foot section, I actually can use 3 panels there. So just kind of picturing what that looks like. So is there another way of figuring this out? Well, what we're doing is we're saying, yeah, I want to see how many 2/3 fit inside of 8.5. Okay, that's what I'm thinking about this side, but I'm also doing it for all the sides as well. So the first thing that I did is I recognized that, and there's a couple ways of approaching it. So if you did it a different way, that's okay. As I want to say, well, the whole thing is a rectangular garden, so I have a perimeter for what the whole distance around. So I went ahead and added up all my sides. 8.5 plus 8.5 is 8 and 8, 16, plus a half is 17. So I know I had 17 feet around these sides. And this side was 6 plus 6 is 12, and a third plus a third is 2/3. So I knew I was looking at 29 and 2/3 as the whole distance around the garden. So I'm going to rewrite this as an improper fraction. So 3 times 29, I multiplied that out, and 3 times 29, I'll show you here, 3 times 29 is 87, and then I add 2 more for my 2 right there, and I get 89 over 3. And what I want to do is I want to take that length and I want to divide it by 2/3 sections, because that's the width of each board. I want to see how many 2/3 I can chop that length into, right? If I did 2 feet and I divided it by 2/3, that meant to do what? That was 2 times 3 over 2, and you multiply it out and we had 3, and we can see how we got 3 sections, or 3 panels in a 2-foot section. So this is like a small version of what I decided to do on a big version. This is 2 divided by 2/3. Here I'm going to do the whole perimeter, 89 over 3 divided by 2/3. So I rewrite this 89/3 times 3 over 2. I cancel out the 3's and I'm left with 89 over 2, which is not a very nice number. They don't reduce anymore. So if I just use a calculator or to solve this out, this actually becomes the decimal equal to 44.5. So in order to do the whole perimeter, I would need, I can't probably buy half a panel, I'm going to need 45 panels to go around the whole thing. So it's a great little problem there. If you get stuck, go back and think about how this one worked out, and then apply that to the big part there. That's it for today. Have a great day, and we'll see you next time.